Hi everyone, this is Zhong Wan. Today is April 21st, 2021. In today's video, I'm going to go through my research updates since the past week. From the past week, I'm still working on the deep learning workflow in the data view. As we introduced in the past week, the prediction score or testing accuracy in our current CUDA implementation is not as good as existing libraries such as PyTorch, TensorFlow, or Keras. So what we can think about the reason might be the optimizer we're currently use, that is SGD, which stands for Stochastic Gradient Descent, which is a very basic version of the gradient descent in neural network, and which can easily result into local optimal and cannot result into very good result. So we're thinking about to maybe we can implement more premium optimizers such as like Momentum and RMS and Atom. So in the past week, I was working on to implement Momentum in the data view, and right now it's available and we're able to use it during the training. And the good news is that RMS and Atom also have very similar feature structure and can be add-ons in the future, because the add-on is based on Momentum and RMS. So basically you will reuse the same parameters in the same objects. So that can be a good thing to move forward. And also I tried multiple times accuracy with using the Momentum is not as good as the existing libraries as well. I also have several trials have been taken, including alternative mathematical implementations. For example, which term should be first and which term should be second, and also the alternative CUDA indexing. That means we can use different 2D or 3D or 1D to align the different cores to calculate different place in or different elements in a matrix. So all of them are not delivering good result for now. So I think further debugging in the code is needed, and now it's in the process. Maybe we can try to review a little bit about Momentum, the details of implementation. So here is the equation. We're going to use the DW and DB and to calculate the VDW and VDB, and this field will pass from iteration to iteration. So here is VDB from the last iteration. So we're going to calculate it by times of beta and then plus this item to get the current iteration's VDB, and we're going to update the weights not based on DW but based on the VDB. So this is a general idea. So here is a code how we implement this. For example, like in the linear layer, before we are able to update the bias or weights with a pure SGD, and right now we are able to update the bias or the weights with the Momentum. And here is a method to update the weights. Here we're going to calculate the VDW based on the last iteration's VDW, and this one will attach to these objects. For example, like these linear layer objects, iterations from iteration. So we can always get the last iteration's value and calculate the current VDW. And finally, we're going to update the VDW on the weights. And also similarly on the bias, we are able to calculate the VDB. But first thing is we're going to calculate the dB, and dB is something we have to do the summarize based on the dz. So here is one of the equation. I think that will be clear to illustrate how to calculate the dB. So this one will be a summarize based on a row of dz, and so it will associate with multiple cores in the GPU. So we are going to use one method that is called the atomic add, and this one will add multiple values based on different range into a single field. Here we're going to add to this dB, and the element row is a dzy. So this is how we calculate the dB, and then we calculate VDB, and finally we can update the bias based on this VDB. So I think that's pretty much the implementation. Maybe more associated with fields and objects, but this is a main change. So I think that's pretty much, and I think I may spend more time in the debugging and print out the intermediate values, because this neural network is very big and complicated work to be debugged. So I think hopefully we can have some good news and good output soon. Thank you so much for your time. I hope you enjoyed this video. Until next time, happy coding.